Assalamualaikum warahmatullahi wabarakatuh. So today, our group will be presenting about timber wall system in construction. So first of all, we will go through the contents first. So for our video presentation, will be firstly about a little bit of introduction to sheathing and framing, and then followed by balloon framing, platform framing, wood stud framing, wood post and beam framing, stud wall sheathing, and then wood columns, and then lastly about post and beam connections. So here are the members of our group, which is firstly me, myself, Luqman Azli, and then followed by Aiman Nabil, Naim Mudassir, Haziq Daniel, and then Nurin Nabila, Nur Arifah, Nurul Shazwin, and lastly Atika Suhaizan. So first of all is the introduction to framing. So framing is the fitting together of pieces to give a structure, support, and shape. So framing materials are usually consist of wood, engineered wood, or structural steel. Framing also includes the vertical and horizontal members of exterior walls and interior partitions. So these members, referred to as studs, wall plates, and lintels, serve as a kneeling base for all covering material and support the upper floors, ceiling, and roof. So these two pictures here are the example of timber framing. So next is a little bit of introduction to sheathing. So sheathing is covering or supporting structure that has a similar function to the sheath of a blade. That is, it acts as a cover or case. The term sheathing or sheathing board can be used to refer to a layer of board or panel material that forms a part of floor, wall, and roof assemblies. The outer sheathing board strengthens the assembly, provides a surface for other materials to be applied to, and may give some degree of weather resistance. Now, as you can see here, these two pictures are the example of application of sheathing. So these two pictures here are the example of application of sheathing boards being applied to framing structure.
So we start off by I will explain about the first type of framing, which is balloon framing. So balloon framing is actually a multi-story timber frame structure, which is the stud that run continuously from the saw blade to the rafter blade through the whole building. So for example, as you look here in this picture, this is the example of the balloon framing structure. So if you look here, this is actually a two-story building, and the stud is actually running from the saw blade through the roof plate. So it's actually a single stud that runs from the bottom to the top part. So if you look closely here, this is actually how they install the flooring or the ceiling. So the joist is connected through the stud using nails, and the extra ribbons down here, or we call it ledger. Usually it is a 1x4 ribbon which support the joist to stay and the constructors can do the flooring or the ceiling better. So this is the ribbon, how it connects with the stud here. This actually is connected through the stud with some nails also to help it support better for the joist here and the flooring. So for the construction method for balloon framing, it's actually the constructors started construct to erect the corners first, and then they also erect the bracing to help support for the whole building. So actually the bracing here is actually helps to make the whole construction even stronger. So after they erect all the corners, they install the roof plate, and also they install all the stud. So actually the stud here is, the length of the stud is actually 2-story. So for example here, if you look at here, if they want to make a 2-story building, they have to install 2-story height of the stud. So after they install the stud, they install the joist here, the ribbon first, and they install the joist for the flooring. So this is actually how the balloon framing. So if you look here, this is clearly, you can see that the stud is actually running straight from the bottom to the roof plate here. So actually it is a single stud. It doesn't have to be a two-part of stud for the whole 2-story building. It's actually using just a single stud from the whole part. So balloon framing actually has a lot of advantages and also disadvantages. So for the advantages, one of the advantages is it is greater strength to resist high wind loads. So if you look here, if there is a hurricane, and usually you can see some building that doesn't rain, This actually mostly is because of the bracing here that helps that helps support the framing, the wood timber framing. So this is actually the lateral bracing which help to make the whole framing structure become stronger. So actually this is not a balloon framing, but this is for the platform framing. So this picture here I just want to show about the bracing. So the next advantage is it is less amount of vertical shrinking, since the usage of balloon framing is actually just a little less amount of wood that used compared to other types of framing. And the disadvantages is it is require longer framing members, since it is of course if we want to build a multi-story, so we have to have a longer studs or longer framing members. So the second one is less efficient during construction, since it is very long and it is very hard to erect. And the last disadvantages is it is spread fire fast and easy from floor to floor. So this actually this one is the reason why the people nowadays, the constructors nowadays doesn't apply the balloon framing a lot for this building. So if you apply the balloon framing, it's actually created multiple void spaces around the whole building. The void spaces is created in the middle. It's created between each stud of the building. So if you this is the stud, and every single spaces between each stud created a void spaces that helps it helps. So for example, if the fire occur in the first level here, so the void spaces help the fire to run through these void spaces and go to the next floor. So the fire will spread very easily. So this is why constructors nowadays doesn't use balloon framing. But to solve this problem, this is the example. If you stand from the lower part, from the ground floor, for example, and if you apply balloon framing, you can see the second floor or the upper floor from through these void spaces between the stud here. So how do they solve this problem? Is actually they apply a fire blocking here. So this fire blocking is put between the stud, and for example, if the fire start to occur from the lower level, it will the fire blocking will at least delay the fire to spread and reach the next level. So I think that's all for balloon framing.
Okay, thank you Amananda for presenting the balloon framing. So now I'm going to present for the platform framing. So basically, platform framing is when light wood having studs only one story high, regardless of the stories built. Each story rests on top plates of the story below or on sill plates of the foundation wall. So basically, platform framing is when studs only one story high. Difference with balloon framing, the stud is one from the bottom to the upper part, but this one stud only for one level and another stud for another level. So this is the concept. This is one level, and it has studs here, a series of studs for one level, and another series of studs. This is the floor for the second level. So it is platform framing is also referred to as western wall. Then we go on to the detailing. This is the joist for the floor as we learned before, and this is the double top plate as I said earlier. This plate will carry the loads above through the stud to the foundation. This is the sole plate to support the stud here. This is the stud, the vertical wood. This is the subflooring, and this is the rim joist. And then this is for the side view. This is the floor joist. As you can see, this is the joist. This is stud and another stud. This is the double top plate. As I said earlier, it is a stud on top of the lower level's top plate. This is the lower level, upper level, one stud, another stud, and divided by this joist. Meanwhile, for the balloon framing, one long stud interlocked by one floor. Basically, it is like that. So this is how it looks like in a whole building. This is two-story building. One series of stud here for one level. This is bracing to support the corner wall, to support the wall, and this is the joist for the floor, subflooring. This is studs, and this is the roof. So this is how it looks like in real life. The first level and the second level. The studs here divided by the floor and another series of studs. So stud walls are also adaptable to offsite fabrication as panels or tilt-up construction. Offsite fabrication is like this. It is made in the factory and you move that to your site. Meanwhile, for tilt-up construction is like this. From landing here, you bring it up like that, as this video shows.
These walls are going to be load bearing.
It's from this condition. It will bring up like this.
The studs are going to want to react to that
And then
load. So
it will be supported by this kind of wood
for the wall system. So
until the paneling was done. So
when they put the wall,
and then for in real life, they did not do a whole big panel of stud here. Instead, they do divide the walls into few parts so that because the bigger the area, the heavier the walls will be. So we want to reduce the weight of the wall and the load. So they divide it into a few parts like this.
you're going to notice here, higher wall,
And they bring up like that, just
you
like
can imagine,
this
the
one.
larger
And they
section
have
wall
this
you build,
they have this connector here. This is the top plate, double top plate. From the double top plate, they do it like this so that the load can be transferred to the top plate here equally to the studs. Okay,
in the installation. See here, and it gets tied
this
together.
is how
So
it looks
now,
like, and this process will be continued for the perimeter of the level itself and also for the interior of the level like this. And it will repeat for the next level, each level. So this is the difference between balloon framing and platform framing. So for the platform framing, one stud here for one level, another level for another series of stud. Meanwhile, for the balloon, one long stud here for the whole building, from the foundation to the roof. Meanwhile, for this, for platform, from foundation to the top part of the level, another level, repeat the same thing. It's like from platform to platform, so it becomes platform framing. So this is another diagram to show that. It's like one stud divided by one floor, but this one stud interlocked by floor. So this is for the fire travel in between balloon framing and platform framing. So what do you think? Which one do you think that spreads the most? So let's see.
In the platform construction, while fire extensions to the floor above is possible, it will be substantially delayed due to each floor being built separately with natural fire stops.
As you can see, this is the this one is balloon framing, this one is platform framing. The fire starts from the bottom. For balloon framing, it goes up straight to the walls. Meanwhile, for platform framing, it goes by level. So you can see here, the whole level was burned, but this one, it keeps going up onto the roof.
Or start below and work its way up.
It keeps spreading and spreading until the whole building burned. So this shows the conclusion between balloon framing and platform framing. Which one does fire travel dangerously the most? As you can see, this one is for balloon framing. The whole building was affected, can be affected. And if you imagine, the fire can go through here, and the whole building will shrink. But this one level only affected, and still can be repaired. So that's all for platform framing. We move on to the next one.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurmila Mitahari and my magic number is 2016214. So now I'm going to explain about wood stud framing. Okay, what is wood stud framing? Wood studs are vertical pieces of wood that help from the framework, which is the part of a wall or a partition. And stud in Old English generally means prop or support. And these are vertical pieces of wood positioned at closely spaced intervals to form the framework of a wall. and it is vital for anyone that interested in buildings and renovations and for installing shelves and cabinets on the wall. Okay, what is the function of the wood stud framing? Okay, the first one is the studs will carry vertical structural loads, or as part of a partition wall may be non-load bearing. And for the load bearing walls, typically use a double top plate. A single top plate may sometimes be used if the rafters, trusses, or joists bearing down on it are directly over the studs, and they are typically sandwiched between top and bottom plates and equally spaced. The spacings will be governed by the size and spanning ability of the facing or cladding materials. And lastly, studs are also hold in place windows, doors, insulation, interior finish, utilities, and so on. And in order to form interior and exterior corners, intersecting walls, headers, jambs, and sails, stud can be bundled together. Okay, what is the properties of the wood stud? Okay, so timber studs are easy to use as it is lightweight and adaptable, and it also can be clad and infilled with a variety of materials to give different finishes and properties. Also, they should be prepared or planned material to ensure that the wall at constant thickness with parallel faces, and care must be taken to ensure that timber studs are completely dry when installed. Otherwise, they may be prone to shrinking and twisting as they dry out. Lastly, to ensure they do not become damp, they should be stored carefully on site before usage. How far apart are studs? Okay, there are two distance or measurement, which is the first one is the 16 inches on center, and the second one is the 24 inches on center. For the 16 inches on center, it's usually for the load-bearing wall, and it is predictably spacing lets you easily find stud when trying to hang a picture, install shelves, or put in new kitchen wall cabinets, among other projects. And for the 24 inches on center is for non-load-bearing walls that can have vertical stud space as far apart as 24 inches on center. Since non-load-bearing walls only bear the weight of drywall and some electrical and plumbing work within, it is possible to have wider apart stud. Okay, next is how it is fastened end to the plates and how it works. Okay, traditionally it is fastened end to the plates by hammer and nail and then by nail gun. But in this modern era, the techniques such as screw, fasteners, clips, and ties are being used to enhance resistance to wind and seismic. And the second one, the wooden wall studs are more common and less expensive than steel studs, which they generally come in two dimensions, which is 2x4 or 2x6. And then the next one, they are both come at a standard length of 92 till 5/8 inches, but you can buy them at various lengths up to 16 inches. Wooden studs can be purchased from any building supply store or lumberyard and are usually made of spruce or Douglas fir. And typically houses are built using 2x6 for exterior walls and 2x4 for interior. And studs are positioned perpendicular to the wall. They are forming to give strength and create space for wires, pipes, and insulation. Next, the studs are sandwiched between two horizontal boards called top and bottom plate, and these boards are nailed and screwed to the top and bottom ends of the studs, forming the complete wall frame, which is spaced 16 inches or 24 inches apart. And this distance allows them to line up with the edges of standard 4x8 feet sheet materials, which are fastened to the stud frame after construction. And the stud frame construction isn't new, and most new homes in North America are still built this way because it is fast, expensive, and surprisingly strong. Okay, so now I will explain about the studs position, and the studs that used to frame around window and door openings are given different names. So we will start with the A letter, which is the sole plate, and also known as the floor plate, which is the bottom stud. Okay, then B, which is the stud itself, which is the wooden vertical frame, and C, the fire blocks, which is between the studs, and then D, which is the cripple stud, which is the stud that located either above or below a framed opening that does not run the full height of the wall. This one. Next is the header, which is known as a window header, and if it oversized, it may be used to eliminate short cripples. F, which is the trimmer stud, or known as jack, which is the stud to the left or right of a window or door that runs from the bottom plate to the underside of a lintel or header. Next one is G, the king stud. The king stud is stud to left or right of a window or door that is continuous from the bottom plate to the top plate. And the next one is the rough seal. The rough seal is known as the window seal. And the last one is the triple stud corner, or also done in double stud. Okay, how to find wall studs? Okay, there's an electronic device called a stud finder, handheld, which the stud finder are small handheld tools you slide along the finished wall surface. And the stud finder scans the density of the wall and it will show where the studs are located. And it is simply can make a mark on your wall where the stud finder beeps and will find something solid underneath the hole to hold a nail or screw. Okay, this is the differences between the wood studs and the steel studs. Okay, for the wood stud, it comes in standard size and found in every home center and lumber yard. And it is inexpensive and also easy to cut, but it can rot especially around the bottom of the walls. But for the steel studs, it is predictable quality, which is it have better quality where it does not bow or rot and it will not rot, but it is difficult to cut and hard to find.
Now I'm going to continue to tell about the wood post and beam framing. So first of all, what is wood post and beam framing? So as you can see in this picture here, you can see a vertical part of woods and then there are horizontal parts of woods. So before that, I'm going to tell about the basic system of post and beam. So as you can see in this image here, post and beam construction. So what is it? It is actually a framework of vertical posts and horizontal beams. So it is as simple as that. You just need a vertical post and horizontal beams. What it is used for? They are used for carry both floor and roof loads. To where? To the foundation system. So basically, post and beam construction is a framework of vertical posts and horizontal beams for carrying both floors and roof loads to the foundation system. As you can see this picture here. So this is an example of timber post and beam framing. So as you can see in this picture here, this is a simple house, wood by timber. So as you can see the horizontal beam here and the vertical post for the parts of the walls. So let's move on. This is another example, obvious example of timber timber post and beam system. You can see the post here on the side of the building, and you can see the beam for the floors and for the roof. So post and beam system, the beams, as you can see this red circle here, beams are used for supporting the floor and roof system, the loads, and then the loads will transmit into posts and columns, which is the vertical parts, and then all loads from the roofs and floors carried to the foundation. So actually, post and beam system is a three-dimensional structural grid which may be expanded vertically or horizontally because all the loads are not put on the walls. All the loads are put from the beams to the posts to the foundation. The skeleton frame of posts and beams is often left exposed to form a visible framework within which non-bearing wall panels, doors and windows are integrated. So as you can see in this picture here, there are gaps between the posts and between the beams. So they will put windows, doors there because they can put it there. See, this is the close-up of the picture. You can see there is a walkway here between the posts, and then there are windows between the posts also and between the beams. They can easily adjust and put whatever they want between the posts and beams because unlike load-bearing walls, there are no loads that being put on the wall, so that you can easily add windows and doors between the posts. When the post and beam frame is left exposed, as is often the case, careful attention must be paid to the species and grade of wood used, the detailing of joints, especially at beam-to-beam and beam-to-post connections, and the quality of workmanship. So when the post and beam are exposed, of course you want them to be good quality and beautiful because everyone will see that. So the detailing of joints is increased. The species is also very important for the quality. So this is the problem and solution of wood post and beam framing. So lateral wind and seismic force can collapse the wood post and beam framing. As you can see this picture here, they can collapse sideways when there are winds or whatever force from side. So what is the solution? So the solution is diagonal locking or bracing. So they put like a diagonal wood between the post and beam so that structural strength is increased. So this is the heavy timber construction and requirements for timber posts and beams. Beams and girders not less than 6 inches in thickness and 10 inches in depth. For the columns, not less than 8 by 8 nominal, which is 7.5 times 7.5 inches when supporting floors. Not less than 8 by 6 nominal, which is 5.5 times 7.5 inches when supporting roofs only.
Okay, for the next slide, we move to stud wall. So what is stud wall? Actually, stud wall is a vertical framing member in a building wall of smaller cross section than a post. It's like a post but smaller, and it looks like a frame. And next is stud wall sheeting. Stud wall sheeting strengthen the wall system by tying the framing studs together. It provides a surface for application of many materials. So basically, stud wall is like a frame, and stud wall sheeting is like we paste the sheet on the frame and it becomes a wall. Okay, next. Okay, the rated panel sheeting. Alright, the rated panel sheeting use the nailable base used for exterior siding, and this is the nailable base. It have 3 per 8 inch thick and use minimum of 16 inch stud spacing. That means the minimum of distance of the stud is 16 inch. And the joint spacing, this is the joint spacing between 2 sheets. So the joint spacing is 1 per 8 inch unless otherwise recommended by manufacturer. So when apply sheet horizontally like this, we have to stagger vertical joint. Like this is the first one and this is the second sheet. So we have to stagger the vertical joint. And for the horizontal edge must be supported by ply clips. Provide supports to panel edge or nails. So this is the horizontal edge. It must be supported by ply clips to make it more like strength. So next we move to gypsum sheeting. So for the exterior siding, this is the exterior siding. It must be nailed to stud frame because gypsum board is not a nailable base. For the corner bracing, this is the corner bracing. Apply 1 per 2 inch panels vertically and nail or use adhesive according to manufacturer's recommendation. So it must be applied by panel vertically to make it more like strength. And then when apply sheet horizontally like the other sheeting, we have to stagger the vertical joint. This is the first vertical joint and this is the second vertical joint. And it must use 8 inch nails. And for the horizontal edge, this is the horizontal edge, we have to support it with blocking. So what is blocking? So the blocking is, this is the blocking. Blocking is use of short piece blocks of dimension lumber in wood frame construction. Use include filling, spacing, joining, or reinforcing members. It like to support the wall. The next we move to fiberboard sheeting. The fiberboard sheeting have high density panels, may be used as nailable base for exterior siding. So for the exterior siding of this sheeting, we must use the high density panels. And the stagger vertical joint need to be used when panels applied horizontally, just same to other sheeting. And the last one is solid blocking or V-groove joint along horizontal edge. So at the horizontal edge, we must use solid blocking or the V-groove. So the last one is rigid foam plastic sheeting. So the exterior siding must be nailed directly to stud frame. So this is the exterior siding. It must be nailed directly because the foam of plastic is an effective vapor barrier. The wall assembly must be properly vented. And for the exposed surface, we must protect it with treated plywood and stucco. Other than that, the rigid insulation, this is the rigid insulation, is for the better thermal insulating properties of the barrier. Other than that, it also reduces a building's energy and help control indoor temperature. So that is from rigid foam plastic sheeting. Alright, the benefits of stud wall sheeting is it makes the walls resistant to twisting and bending, and it helps shield a building from rain, snow, and wind, and it also bracing the wall against positive and negative force. So the wall is like strength and it hard to be collapsed.
Assalamualaikum, my name is Naratika with magic card number 2013178. So now I'm going to present and explain about wood columns. So what is wood columns? The term columns is typically considered to mean any compression member, including compressive members in trusses and posts, as well as traditional columns. The design of wood columns is limited by the material stiffness and strength parallel to the grain. It's frequently used to support the weight of the roof and or the other part of the floors. In selecting a wood column, there is the criteria that should be considered, such as lumber species, structure grade, modulus of elasticity, and shear stress values permitted for the intended use. In addition, attention should be paid to the precise loading conditions and the types of collection used. Next, there are three types of wood columns. First one is simple solid columns. Second one is space columns, and the third one is built arch columns. For the simple solid columns, it is consists of a single piece of wood, rectangular in cross section. There are many types of wood columns can be used. For example, stone lumber, posts, timbers, poles, glued laminated timber, and many other more. So basically, it is a single solid block. As you can see here in this picture, this is the simple solid block columns at the back of the building. And this is the example of glued laminated timber that is attached to the wall. Next is space columns. It consists two or more parallel single members separated at specific locations along their length by blocking and rigidly tied together at ends by timber connectors or bolts. So this is the structural of the space column. This upper part is called as end block, the same as the lower part, also called as end block. In the middle part of this space column, it is called as spacer block. So this column has a individual shafts spaced apart by end and intermediate paging piece, which is the spacer block here, and the end of the block here will have a space between them. So this is the other word of end block is end paging piece, and for the spacer block, the other word is intermediate paging piece. This is from the front view. As you can see here, there is a space between the end of block and the spacer block, so that is called as space columns. Next is build-up columns. It consists of two or more members joined together by mechanical fasteners that is assembly as a single unit. As you can see in this picture, there are 6 members of solid block that we joined together to the wall. It can be a single big block with 2 rectangular small blocks on both sides. It also can be a square block with 2 rectangular on each side, and it also can be like this. So, good laminated columns may have a higher lower compressive, while mechanically fastened columns cannot equal the strength of a solid column of the same dimensions and material. Last but not least is the benefits of using wood columns. So compared to concrete and steel columns, wood columns has much more benefits, which the first one is can increase insulation, meaning that it can reduce heating and cooling costs. Second, since wood absorbs moisture, it helps to regulate the balanced humidity in space. Wood column also can be manipulated to redirect sound reflections, resulting in structural and acoustic balance. And lastly, it has an excellent strength to weight ratio better than concrete and steel columns. That's all for wood columns. Next, I will pass it to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Arifah binti Nordin, method number 2012808. So today I would like to present my part, which is wood post and beam connection. So there are several types of wood post and beam connection, which is plank and beam framing, post bus support, column support beam, split ring connector, floor and roof connection, and post and beam relationship. So first is plank and beam framing. So as you can see, there are two levels, which is the first level, second floor, and roof. So the second floor and the first floor is connected by posts, which is post is discontinuous, but each segment is aligned to bear directly over each beam and each other. And also for the second and roof, they are used the same system as second and first floor. So next is post base support. Post base support has two types, which is ankle strap and countersunk head and knights. For ankle strap, the post is connected to the foundation using the ankle strap, and the ankle strap connected to the post using two bolts. And space may be required between the post and the foundation, because if there have a moisture problem, which is if the wood expand, there will have space between the foundation and post to expand. Next is countersunk head and knights. Countersunk head and knights connect the foundation and post using bolts also, and the steel plate welded to the base. Next is column support for beams. There are 6 types of connectors, which is beam hanger with concave length, steel anchor with web stiffener, bearing block bolted to the column, space beam routing on built-up column, curved beam set into steel plate, and diagonal brace connection. Next is general guideline for the placement bolts using diameter of bolts. There are 2 types, which is load parallel to grain and load perpendicular to grain. If there is insufficient surface contact area to accommodate the required number of bolts, a split ring connector can be used. It spreads the load over 2 larger area width and develop higher stresses per unit of bearing than a single bolt alone. And as you can see, this is the split ring connector that can spread the load over a larger area. After that is post and beam relationship. There are 3 types of it, which is 1. Solid beam and space post or column. 2nd, space beam and solid post or column. And 3rd, beam bearing on column, which has connected in the middle of it. And it will become like this. Wall connection also related to floor and roof connection. And this illustrates various foundation, floor and roof system connection to post and beam walls. Please note that beams are integral parts of both wall and floor of roof system. The type of floor and roof system used and how they are supported by the wood posts or columns affect the construction depth of the floor and roof planes and the overall height of the structure. This is how the wall connected to the floor and roof. This is beam and rafter roof, and beam and joist floor. And this is concrete ground slab, beam and joist floor, and beam and purlin roof. This illustrates the wall relationship to post and beam frame. This is the continuous exterior finishes, while this is the interior finishes. And inside that is wall frame and insulation, and walls and posts in the same plane. This is additional piece can be used to let the finished material eliminate through joints and form a seat for the attachment of the wall frame. And last but not least, the strength of a post and beam connection depends on, first, the thickness of the wood members, second, the species and grade of lumber used, third, the angle of the resisting force relative to the grain of the wood, fourth, the size and number of bolts used, and last, the use, if any, of timber connectors. And it also can be summarized that the size and number of bolts required for a connection depend on the magnitude of the loads being transferred, and greater efficiency is achieved with a few large bolts rather than with more smaller ones.